Hello, how's it going, everybody? Good afternoon. I'm Somik Behera. I'm a product manager at VMware's core NSX platform team. Briefly about me, I was part of the Nigeria team before VMware. The initial members of the product team. I was also one of the founding members of the OpenStack's networking project, OpenStack Neutron. And today I'm going to talk to you about our network virtualization platform, NSX, why you need it, how you create it, how you deploy it, and what are the key use cases you should look at it. So with that, let's get started. So, as I said, we're going to discuss network virtualization deployments, why you need network virtualization, and how you can achieve it with the NSX platform. And we'll understand simple packet workflows, little deep dive into, how does NSX work? How do you actually, you say network virtualization, what does it mean to be virtualized? What does it mean to virtualize a network, and how we do it at a packet walkthrough level? And then wrap it up with key use cases that our big customers are achieving by using NSX network virtualization. So, the benefits of network virtualization, before I cover that, I'm going to first talk about, what is network virtualization? That's a fundamental question. You might have heard a lot about it. What we view as network virtualization is complete decoupling of the physical network from the virtual network. Just like general purpose hardware, x86 processors and general purpose hardware was used by VMware to virtualize virtual machines, and the requirement was I need x86, right? There's no other requirement, no complex topologies to virtualize your VMs. And on that, there was VMware's hypervisor, which is a thin layer of software, which went on top and created virtual machines on top of it. Similarly, NSX just requires IP connectivity, just plain L3 connectivity. And our thin layer of software, network virtualization software, which is NSX, sits on top of that at the hypervisor level and at the edge of the virtual network boundary, and creates virtual networks and all the virtual network services from L2, L3, L4, and L7 level, right? And workloads consume these services by calling a programmatic API, and for which there are a lot of benefits. And the key element here to take away is that for a network to be virtualized, the physical hardware is fully decoupled from what is there in the virtual network. The virtual network should not have any dependency on the physical hardware. In the same way, virtual machines don't have any dependency on the server hardware up till it's x86. Similarly, for virtual networks, they just need L3 connectivity, and they're good, right? So with that point, I'm going to go a little bit why people are using NSX. Number one is, business agility. This is a quote from one of our customers for whom it would take at least 7 days, and a lot of other customers would take weeks to provision network infrastructure before you can get the applications up and running. From there, because of network virtualization and the speed programmatic API-based provisioning provides you, they went to seconds. That's huge, right? From innovation that you can achieve when you have that kind of speed up in your IT processes. The second is cost savings. Because now you can have simplified IP hardware or IP fabric. We dramatically simplify your network architecture. Operational speed increases. So some of our customers have achieved operational savings as much as 80% than pre-network virtualization era, right? That's great. The cost savings is the next important use case why people virtualize the network. And finally, choice. Well, what do I mean by choice? I mean the choice of any network hardware that you want, any hypervisor that you want, and the choice of integrating with any cloud management platform. And you can non-disruptively insert NSX software, and underneath it, you can upgrade your network hardware. And your application will never feel any difference because they're fully virtualized. It makes it easy to remove and upgrade physical network hardware. Similarly, you can move applications and have connectivity across different hypervisors, and that's how we enable choice. So in a nutshell, what does NSX provide from a feature perspective to realize the key benefits that I just talked about? It provides the full suite of networking functions in software, starting from switching to routing to firewalling, to load balancing, to VPN, and all of it provisioned programmatically using NSX API, which gives you the dramatic speed up in provisioning and deployment time, especially and helps you innovate. And the final component is we don't only do network virtualization. We don't only provide you L2 to L7 services. We do so with all the leading, a plethora of leading ecosystem partners who have network and security hardware. They seamlessly can integrate into the NSX ecosystem, and we are coming to market with NSX solution with the ecosystem of hardware partners. So if you have existing investment in F5 load balancers, if you have existing investments in firewalls, we are going to integrate them into this virtual network because we are not going to do everything. So your existing investments, and there are companies which do it a lot better than we will ever do, and we will integrate and make it seamless to automate all of it in a single pane of glass. Right. With that, I'm going to briefly go over the NSX architecture a bit, and go over the components which we use to realize the NSX deployment. So at a high level, what does NSX have? It has at the data plane layer, there's a virtual switching element, which actually does the connectivity, packet forwarding. That's the NSX vSwitch. And we have some elements, the NSX gateway, which actually lets at the data plane level establish connectivity to external networks or your existing enterprise physical networks, or provide connectivity from virtual machine to the physical servers, which don't have a vSwitch. That uses the NSX gateway as a data plane element. Then the more important element in our architecture is the NSX control cluster, which uses the data plane elements as a vSwitch, as the gateway. And in the future, we are having top-of-rack switches. It uses all of that to realize network virtualization, and this controller is doing the state management of the entire data center's network. And therefore, our key IP is around the controller software, which is very highly scalable and fully distributed, and it scales out. So it shares the workload across multiple nodes in the controller, and as a network size increases, as you want more features and functions, you add more controller blocks, and you get more capacity, right? And then once you have that controller managing these data plane elements, you pretty much are ready to consume it. And that's when you create logical switches, which is our definition of a L2 network or L2 broadcast domain. You can programmatically create it in virtual form factor. You can record it, and you can move it around because now it's an API and it's in software. You can create logical routers similarly. You can connect logical switches, and they're free because they are not essentially free, but they're API-driven. They're software elements, they're software constructs, nothing physical about it. And all of that, you're doing it via an API, which means your traditional network provisioning is now fully automated. And once everything is fully automated, you have less room for errors, right? You remove the human error element from it. So your business is run more efficiently, you have less downtime, your mean time to resolution increases, and all that good stuff, right? So with that, I'll dive down a little deeper into the controller, which I said was the core at the heart or the engine of the solution. Our controller actually creates the virtual network, which is an overlay network. It's deployed in a scale-out platform. Oh. I think we have a little difference in the slides, so that's fine. So there's a switching layer, and there is a control layer, and then there are API. So the controller deploys, essentially creates the overlay network. It actually scales out and realizes the virtual networking model. And it actually manages the state across the thousands of hypervisors we support. And the second element, which is important, is the vSwitch, which is in every hypervisor that we support. The vSwitch, actually, what it does is that takes command from the controller and constantly maps the logical switch state to the physical network forwarding state. So what it's doing is it has a table of mapping, and the controller has pre-programmed it. So that's why our controllers are never in the data plane or data path. They just program the entire infrastructure, and when the VM comes in, the right thing happens. And not only at the data plane level, not only we do switching, kind of forwarding of packets, but this switch supports all the traditional notion of L2 switch protocols that you had come to know, like S-flow, like LACP, bonding, and everything to be, so you can operationalize it in the same way you operationalize any L2 switch. So, and the whole thing, our controller and API ecosystem package is fully, let me fix this slide. Next. Okay, next. Next. Okay, so I talked about the switching elements, and now let's talk about how you actually, just one second. Yeah, how you actually realize overlay, how do we actually build overlay networks? First step is we need a robust physical network, which is an IP fabric. On top of that, once we have L3 connectivity within all the hosts in this fabric, that's what we call an overlay transport area, or an overlay transport network. On top of that, now you can use the API to create the logical networks, or the logical switches, L2 broadcast domains, programmatically, logical routers, which just went up. And those are created using tunneling, L2 over L3 tunneling, and we support the whole suite of tunneling protocols out there, such as VXLAN, STT, GRE, and IPsec. So you have the choice to use any tunneling protocol. And the important thing to take away from this is that what's important is the business benefit you're getting out of network virtualization, not the tunneling protocol. And that's why we are supporting all of them to give you the choice to use anything you want. So here, now that you have created these are overlay networks, you can just, for a second tenant or a second application, you can just, with an API call, add a new network. And then you have a red network with a red tenant, its own L2 domain, right? So there you go. So we created multiple logical switches programmatically because it has now an overlay zone on top of simple IP, L3 IP fabric. So with that, we're going to talk about how does the overlay tunnel work, right? How does the packets Ethernet frame look like? So when you create an overlay tunnel, what happens is that you have the L2 frame, the Ethernet frame, that comes out of the VM, gets encapsulated, whatever encapsulation format you have chosen in our software. You can use STT, GRE, VXLAN, IPsec. There are many encapsulation formats, and that doesn't matter, honestly, right? So we encapsulate, and then we send it over the wire to the destination. Here, the destination happens to be the same hypervisor. It can be any different hypervisor. The receiving hypervisor strips off the encapsulation, the thing you see in gray. Let's see if I can point. Yeah, so it strips off the encapsulation header, and then the end VM receives the L2 frame that it was destined for. And that's how you do tunneling. And that's how you create virtual networks, or that's how the packet flows through, right? So now I'm going to actually go a little bit deeper and show you exactly what is happening at every stage of the pipeline. There's a VM here. That there are two virtual networks. There is the blue network and the green network. Now the blue VM wants to send a packet. So it has an L2 frame. And next, the packet goes to the vSwitch. At the vSwitch level, the vSwitch was pre-programmed to apply network policies such as ACLs, QoS at the virtual network level. So as the packet is exiting the VM and going to the vSwitch, we will apply that, and then we will put it on the transport network. So at that time, you see there is the overlay tunneling headers added to the packet, and it's pumped into the tunnel, into the transport network. Next. Yeah. So now you receive the packet at the end destination of the tunnel, and it has the header. The vSwitch is next going to strip off this header, and it's going to apply any kind of final network policies, any ACLs or QoS that you might have, and then the NVM is going to see the L2 frame, right? So from a packet level, you saw how it's pretty simple, but it's all been pre-configured. You saw the packet never went to the controller. It's all the data plane. It's hardware accelerated related encapsulation when people use STT. So you're getting line rate performance. And it goes from source to destination. And we do the same thing even when you're doing routing, when we're doing ACLs. It's actually at the per VNIC level as the packet is coming out. So imagine firewalling. It fundamentally changes the game when you're now talking about firewalling, right? Now, firewalling is happening at the VNIC level. Instead of going to a choke point, because this is fully distributed, as the packet is entering, you can apply policies right there, which means, for example, before you had a 10 gig firewall, now every hypervisor has 10 gig capacity. So essentially, if you have 10 hypervisor times 10 gig capacity every hypervisor, you effectively have a 100 gig firewall. So that's the power of network virtualization and implementing network service in a distributed manner. It fundamentally changes the game, right? So with that, let me do a quick time check. How am I doing? OK, good. So we also have a capability called the gateway, which allows you to connect cloud servers in the virtual world into the physical world. The way we do it is via an x86 appliance or using TOR top-of-the-rack switches, which are compatible with NSX. And we just bridge the virtual network via the gateway into a traditional VLAN, where you might have, it might be traditional L2 with a bunch of physical servers. So we can non-disruptively now introduce network virtualization and provide connectivity to your existing infrastructure and your existing networks. So with that, we'll quickly go through, we talked about the benefits and how it actually works, but how do you get it up and running? What are the number of steps you need to take? You say it's really cool, it's not disruptive. Tell me, how difficult it is to create my first virtual network from, ground zero. I have my traditional enterprise IT network. How do I get to a virtual network? The first step is you need to have network infrastructure. You need to have a robust network infrastructure, physical network where you can forward packets. We are agnostic of the vendor. You can use any vendor for creating a physical network. It can be an L2 fabric or L3 fabric. We don't care, right? You have a good, robust network infrastructure. Then you're going to install compute hosts with your hypervisor of choice, and you're going to make sure there's a vSwitch in it. If you have KVM or Xen, you'll have Open vSwitch. We're compatible with that. For vSphere, we have NSX vSwitch. The next step is you're going to identify which rack out of these 4 racks you want to be your exiting rack to the, to the north-south, to the outside world, because that's where we're going to put gateways for traffic that has to go north-south outside the data center. And after that, we will go and prepare the NSX components, right? Step 1, we will deploy the controller and the management appliances. Step 2, we're going to register all the virtual switches on these hypervisors or in these racks you see with the controller. Next, we'll probably deploy a manager in the same rack as the controller. The manager just provides you visibility and gives you a tool to operate this environment. And then, whichever rack we have chosen, rack 4 to your gateway to outside world. And over here, we're going to install the NSX gateway. Or we're going to plug in the physical top of the rack, which is compatible with NSX. And that's it. NSX deployment has done. Like that's the 4 steps. We provide you all the infrastructure to automate that deployment. And then the final step is now you're ready to integrate your cloud management platform. So with regards to cloud management platform, we provide out-of-the-box integration with a variety of, with a whole bunch of cloud management platforms. There's out-of-the-box integration with OpenStack. We have NSX plugin for Neutron. There's out-of-the-box integration for CloudStack. We were the first non-native integration into CloudStack environments. There's out-of-the-box integration to VMware cloud management platforms, such as VCD and vCloud Automation Center. And that's it. You register it with the cloud management platform, and you're ready. You're ready to use that cloud management platform to create virtual networks, to create applications, and get the benefit of everything that NSX provides that I was talking to you about. Cool. So, okay. So to recap, 3-step process: have a robust physical network, install the controllers and register the virtual switches from hypervisors, install gateways, register NSX with your cloud management platform, and that's it, and you're ready to go. So with that, we saw it was pretty simple to get up and going. 3-step process. Most of it is automated to get started with network virtualization. I'm going to now go through a sample app, like a sample app that would take a few days to provision in the physical network. You'll need to create 2 L2 broadcast domains, 2 VLANs. You'll have to configure them, and you'll have to, they need their own router, etc. So here we'll take this app, and we'll see how it can be deployed really quickly in a virtual environment, right? So we have this logical topology where there are multiple hypervisors. There's KVM, there is vSphere, there's ESX. They can be Xen or Hyper-V, and they need 2 switches that connected logically at this topology. Now to automate, to deploy that, go back, yeah. We realize it by, the packets, the VMs will be on these hypervisors, and they will be tunneled to its destination, and it can work across KVM and ESX because we encapsulate it, and we have line rate performance, and no matter which hypervisor you choose. Now, to see how it actually works, this first step is that all the hypervisors are connected to an IP network. Next step, the cloud management platform can be OpenStack, talks to the NSX API, the NSX controller via our NSX plugin in Neutron, and it creates this virtual network topology. 2 tenants, 2 virtual networks, each has 2 virtual ports and the 2 VMs. And then the cloud management platform is going to spin up the VMs, on the hypervisors. At that point, the NSX controller will actually contact the hypervisor and tell them that these VMs are going to be in this particular virtual network. Therefore, they need to have tunnels between those 2 hypervisors. And that's what we pre-programmed it. So no packets will ever flow to the controller. They will go direct from the source to destination. Next, we need a router to egress to the external world, right? So when we created this logical router, the controller will tell the gateways to create a tunnel to the hypervisors for which need to have routed connectivity to the outside world. And now we want the routed connectivity to be connected to the external corporate network, because that's where all of your existing assets exist. And voila, right? You have connectivity end to end. And configuring this whole environment will take a matter of seconds because it's all API driven. And you can integrate seamlessly with your existing applications because your existing corporate network kind of connects through to the virtual network. So with that, that's one part of the benefit you got out of virtualizing the network. You essentially took an application that would have taken days or weeks in the prior, and as you see, how we realized it in a matter of seconds and how it actually worked. Now, a lot of people ask me, how do you have visibility? How do I monitor this? It's great, you're saying that the benefit of network virtualization, I want it, right? But how do I actually operationalize it? And to that, I want to show you that we have a beta product with our integration with vCenter Operations Manager, which means all this rich data we have that is not, because we're a software-based solution, can be mined, using big data techniques, and we can predict application failure before it happens because it's in software. In this example, you see there's this virtual switch, and we are mining 77 metrics across all of this to say what is the state of this switch. So before its switch goes down, we can predict the switch will go down because we have this analytics algorithms and that are just there in the existing theory of knowledge. We can apply to networking now. And that's the power of virtualizing the network. It actually improves visibility. It actually improves uses analytics to improve troubleshooting. And it becomes more proactive instead of reactive, right? So with that, I'm just going to, we've talked about network virtualization, how to get network virtualization up and running, the benefit it provides, and it actually improves visibility. It improves monitoring. And so how do I use network virtualizing? Why do I use it? What are the use cases I should look at? To that, I would say most of our customers are starting with self-service IT. That's the introduction point to get into network virtualization because every developer wants their own sandbox environment. They want the flexibility. They want the speed to deploy their own networks, own routers, their own environment up and running without waiting in IT ticketing systems. So self-service IT would be a great entry point to getting into network virtualization. That's what you can use network virtualization for today. Another great use case for network virtualization is data center automation, right? Which means a traditional app, it can be even non-virtualized or fully virtualized, and you can micro-segment the app. You can improve the provisioning automation of that app. And you can simplify your compute silos, increase your compute utilization. Because it's a virtual network, now you can spread your VMs across your infrastructure, you can peanut butter them, and you can have higher compute utilization and save on compute costs because compute capacity is not siloed. And finally, what our leading customers are also doing is creating public cloud infrastructure as a service environments. In public cloud environments, without network virtualization, it is untenable to actually have that kind of agility and provisioning and isolation of networks. That's why the leading public cloud providers are embracing network virtualization and deploying it to create a robust infrastructure. For example, Rackspace uses NSX to provide their customers a public cloud environment which is segmented, isolated at the network layer using NSX network virtualization. Google uses network virtualization by default in Google Cloud. The reason is that without network virtualization, it's not possible to create a good, robust public cloud solution. So with that, I hope you guys found good value out of this presentation, and thanks for your time.